Lesson 2I, Covalent Compounds, also known as molecular compounds. This is a non-metal bond. Remember, the nonmetals are found on the right side of the periodic table. They are often recognized by the negative sign in their cells, as nonmetals tend to form negative ions. In the case of covalent compounds, however, they do not actually form negative ions. We use the negative sign simply to help you identify that it's a nonmetal. Let's look at carbon and oxygen, for example. Both are nonmetals. They are both found on the right side of the periodic table, and they both become negative charged ions. They would chemically combine to make a covalent compound. If you were asked to predict the covalent compound created from two nonmetals binding together, we would simply use the crisscross method, just as with ionic compounds. Let's use carbon-oxygen as an example again. Carbon has a -4 and oxygen has a -2 charge. Now, since we're not actually creating ions, we would rewrite the numbers without the negative signs. We call these oxidation numbers or combining capacities. We'll now crisscross the 4 and the 2, and we end up getting C2O4. With covalent compounds, we do not reduce. Let's look at nitrogen and bromine, two nonmetals. Nitrogen has a combining capacity of 3, and bromine has a combining capacity of 1. Crisscrossing, we get NBr3. Sulfur and fluorine are both nonmetals as well. Sulfur has an oxidation number of 2, and fluorine has an oxidation number of 1. Crisscrossing, we get Fs2. Naming covalent compounds is really easy. It requires the use of the Greek prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. As with ionic compounds, simply change the ending of the compound's name to "ide." Let's look at CO, for example. There's one carbon and one oxygen. Using the Greek prefixes, we get monocarbon monoxide. However, we never start a compound's name with mono, and we don't do double O's, so the name becomes carbon monoxide. N2O, this is dinitrogen monoxide. PCl3 is phosphorus trichloride, and P4S10 is tetraphosphorus decasulfide. Writing the covalent formulas from the names is quite easy. Just read the names as a recipe. Dinitrogen tetroxide. That's 2 nitrogens and 4 oxygens. The formula is N2O4. Don't reduce. Phosphorus pentachloride is PCl5. Carbon disulfide is CS2. And xenon trioxide is XeO3. A reminder of some rules for naming covalent compounds. First, no double O's. Double O's simply become a single O. An example is monooxide becomes monoxide. The same goes for AO combinations. AO simply changes to O. An example is tetraoxide becomes tetroxide. Any I and other vowel combination results in no change. Example, triiodide or dioxide. And finally, formula names never begin with mono. Example, CO, monocarbon monoxide becomes carbon monoxide.